So this is the last in the series of the videos, at least for now, and I'll basically end by looking at rigid lengths and offset beams. So these are things I covered in my lecture last term, so I'd suggest you look back at the notes for that, and also a bit on section modifiers and changing use of materials so you can alter the stiffness of the elements in the analysis. So this is the model we're starting with. Again, I'll pass this to Dr. Vollum to put on the Imperial website. It's broadly similar to what we created before, but I've made a few changes. So for example, I've changed this middle, or added in a section property to make this middle column a square, as you can kind of see from the outline there. And if I make it solid, you can see that that's now a square section. The other thing I've done is I've put it in, well, there was the beam along the edge there, and I've added in a second beam there. Again, if I make the model solid, again you can see the beam there. It isn't offset, and again that's why it's in there, just to give you an example of that. Again, the background is pink. We're working in the design layer. If I press Control Alt and D to switch to the analysis layer, you'll see there's no analysis elements created. So that's kind of where we're starting from. Just for clarity, I'll also turn off the visa grid. So where I'll start is with offset beams. So again, the point of offsetting, or one of the points of offsetting, is that it gives you a better representation of the stiffness. So perhaps you might want to capture the stiffness of the edge of a slab, for example. So if you're looking at doing an analysis to understand the edge deflections. So we've got two beams here, as you see, one spanning from this column to this column, and then one from there to there. And you see the nodes coincide with the nodes of the elements, so it'll be meshed. So it'll all be meshed together with the beam divided into elements based on the size of the elements in the slab. If I just shrink the view so it's easier to see, so you can see we've got, if I do change the beam selection tool, we've got this beam, edge beam. You see highlighted in purple there, and then we've got another edge beam here. So I'm going to leave the beam here as it is, just so we can compare and contrast. But if I select the beam here, so again, it's giving me a choice to cycle between the things which are on that line. So that's the area member that we've defined before, and the edge beam. So that's what we want. So I've selected that, and I click OK. So then if we come over to the right-hand side of the screen where we've defined the properties, so that's the size of the beam. It's 500 deep by 200 wide. So that's fine, that's not changing. But you can see here there's an option for offsets, and you can obviously offset in the various directions. So we're going to offset the beam downwards, so offsetting it in the Z direction. So the slab thickness that we've got is 275. We put that in before. We know the beam height, the overall depth of the beam rather, is 500. So if we want to offset the beam downwards, so the top of the beam coincides with the top surface of the slab, we need to move or offset the beam downwards by 112.5 millimeters. So if I go to my Z, so we're offsetting the beam down the way, I go 0.1125, so 112.5 millimeters. As you can see there, the offset's defined in meters. If I just click return, and what you see, if I put it in solid, is that I've actually forgot to put in the a negative. So if I take off shrink, you see actually what I've done is offset the beam upwards. So now the actual base, or the bottom side of the beam, is flush with the underside of the slab, which isn't what I wanted, obviously. So if I come back, it's still selected. If I go back to the Z, I put in negative 0.1125, and you can see now it's been offset downwards. If I put on the shading again, perhaps if I go to a top view, if I use the volume tool, so the button there, just so we can get rid of a bit of the model, so we can really kind of focus on the bit we're interested in. And I think you can see kind of quite clearly there. So that's the beam on one side which isn't offset, and that's the beam which we've offset down the way. If I rotate the model slightly, yeah, I think there you can see that the top of the beam is flush with the slab, whereas the beam we haven't offset is still above and below the slab. So offsetting is as simple as that. Obviously, as I said in the lecture last term, it really depends on you and what you want to do with the analysis on whether it's actually worth it. So I'm just going to keep this volume on the screen. Obviously, the rest of the model is still there. But just to see what difference this actually makes. So I'll save before I do any analysis. There's no point in doing an analysis because I haven't created any members yet. So I go to Model, Coordination Tools, Create Elements from Members. I want to create the entire model, so all. If I do Control Alt and D, you can see we've now got elements in the analysis layer. I'll turn off the nodes just so things are clearer. And again, you can see the outline of these beam elements. As I said, if I shrink it, you can see that there are individual elements between each of the nodes of the mesh. So again, you've got compatibility between the stick elements for the beams and the 2D elements for the mesh. So far, so good. So now if we analyze it, everything should work, hopefully. So it's a fairly small model, so it analyzes fairly quickly. If I close that, I will save it just in case. So again, just to check what's happening, if I look at just for simplicity at the self-weight case, again, just looking at the self-weight case and deflection is often a good way of checking an analysis. Again, does the deflected shape actually make sense? So the thing we can't see, because I've obviously of the volume, because I've taken the volume of this is a column there, but that's kind of what I expect in terms of the deflection of the slab. So that's the deformed image button there. If I go to a top view, so using the tools at the left-hand side to control the view, equally, I could go to 2D element results, displacements, and go apply. And there I can see the actual displacement. So again, we've got the kind of column points there, so no displacement at all, and a big displacement around the penetration. So again, it's all looking kind of as we would expect. So let's get rid of that. I'll clear that, press apply. But what I wanted to look at is the effect of offsetting the element there. And again, for simplicity, I'll just stick with the self-weight case. So just as a reminder of what that is, I'll put on the loading arrows, and all you see there is, if I just annotate a few of them, that's essentially 6.472, the self-weight of the slab, and 2.354 is the self-weight of the beam. So again, it's a very kind of simple load case, which makes it ideal for checking the analysis. So the thing I'll do, just again for clarity, is turn off these the shapes of the beam on each of the elements itself. Again, just so it's easier to see. So I've got my labeling option up here. So label section shapes I want to turn off. Equally, you could have gone to the labels and display methods button that I'm pointing at now. If you go to elements and members, and you can turn on and off the section shapes here as well. So I'll click apply and that's turned it off. So you can see graphically, that's the indication that the beam has been offset from the plane of the slab. I'll shrink the elements just so it's a bit clearer. But if I go to the element selection tool, and again we're in the analysis layer, but that doesn't really matter. If I click on the element, you can see in the grayed out panel, it's been offset. Again, it's grayed out because we've carried out the analysis the analysis results exist, so you can't change the actual offsets. I think if I went and right click again, experiment with the right click menu, the context is fantastic. I could go to element, I think it's element properties, and you see the report that's appeared at the bottom of the screen, again, which is just a quick summary of the coordinates of the element, the various details, and somewhere here it's telling me what the offsets are. So again, I can select any element, so I'll select a 2D element, for example, here, and that gives me the properties of the elements. It's giving me the node numbers, the node coordinates. So again, it's a quick way of interrogating the analysis. But that's not what I want to do here. I want to look at the actual results. So let's maybe start looking at the bending moment diagram. And all I'm interested in is the actual beam elements in terms of seeing what's happened because of the offset. Anyway, if I go to the right-hand side, and remember the tools that I'm pointing to here are the diagram type tools, typically for 1D elements, whereas the toolbars down here are the kind of color contouring and type displays, both for 1D and 2D elements. But I'll choose the bending moment diagram display there. Again, it's MYY, so again, it's giving you, it's a predefined option. If you wanted to actually choose the direction that you want to see the bending moment in, you would go here to the diagram settings, and you would choose from one of the settings here. You see, because I've already switched on the bending moment view, it's already showing that by default. So I can either alter that. So perhaps I could choose torsion and choose apply, which shows the torsion, as you'd expect. We're seeing a bit of torsion at the ends. Or you could create a new diagram to mix and match a range of output on the same diagram. But let's go back to MYY and click apply. Maybe make it a bit bigger. Just maybe so it's easier to see. So if I choose an element, that's fine. It's reminding me that that's the beams are element property 2. So just so it's easier to actually see what we're doing on the screen, I can go up to the display tool there, where we can actually define what we're looking at. I'll type in P for property, B for beam, and 2, and that just leaves us with the beam elements. So again, it's just a quick way of isolating the things that we want to see. Again, just as a reminder, if you've got a view that you like and you want to keep, if you right click, if you choose save graphic view, excuse me, and I'll go test beam image, just for something to call it. I'll click OK, just save it for my own benefit. Then if you come to the Explorer on the left-hand side, if you go to Views, Save Graphic Views, you can see it's there. So even if I get rid of this, so maybe I choose all, if I go Test Beam Image, it's remembered that, and it's brought me back to the image itself, which again is useful, especially if you're going to kind of revisit the results. Anyway, we've got, if I just rotate it slightly, sorry, we've got this little beam there. I'll take off the shrink effect. So the point that I want to, or the thing that I suppose I'm seeing here, isn't so much the bending moment, because as we saw in the lecture, the bending moment diagram is broadly unaffected, at least in terms of the overall shape. So again, you've got kind of fixed supports or rigid supports, so we get hogging at the supports, we get sagging in the center. So again, that's kind of what we would expect. The offset there is just simply because it's drawing the bending moment diagram on the beam. But as you remember from the lecture, if you offset an element, I'd expect to see an axial force as well, which you then need to take into account. If you look at the design moment, you need to take the bending moment that you see there, and then add on the axial force times the eccentricity to get the design moment. So if I turn off the bending moment diagram, and I turn on the axial forces. So before I do that, I'm not expecting to see any axial force in the beam here because there's no offset, and I am expecting to see axial force there because there is an offset for the reasons I talked about in the lecture. So if I switch on the axial force tool, again, the axial force that we see at the end there is simply just because it's being resolved at the node. But you can see you've got this this axial force changing as you go along the beam there. Again, purely because of the offset element. So if you wanted to test that, so I'm saying this is all because of the offset. So we can test that if I delete my analysis results. If I go to Model, Coordination Tools, delete everything. So again, that's deleted the analysis layer elements. If we come back to the design layer, again pressing Ctrl-Alt-D, so we want to select the beam on the edge there again. So you see it's got an offset. So let's take out the offset. So now it's basically as it was to start with. If we go back to Model, Coordination Tools, Create Elements for Members, we want to create elements for the whole model. I will switch back to my analysis. So I'm not, sorry, I paused the video for a second that I wasn't totally sure what that sort of graphics glitch was. So I just restarted the model so you can see it's gone. But if I switch to the analysis layer, I've deleted the elements as before, get rid of the grid. So you see the beam is again back to where it started. There's no offset if I select the beam itself. Okay, and you see there's no offset defined. So again, if we go to Model, Create Elements for Members, and again, if we want to create a model, want to create the entire model itself, if we go back to the design, to the analysis layer, take off Shrink. If I now analyze this, and again, this is the point, it's very quick to make these changes, so we can investigate what happens with our structures and investigate various modeling techniques. So we're back to the model itself. I'll save this, but I don't need to go back to recreate the view before. So we're still in Views in the Explorer. If I go to Save Graphic Views, I can click on that and I'm back to my image that we had before. So again, you can see it can be really kind of quick to kind of get back to the places that you were, so you can re-examine the actual analysis itself. So again, as before, we've got hogging, support sagging in the center. So again, as we would expect. If I switch off the bending moment, if I put on the axial force, there isn't anything in the beam itself. Of course, why then do we have the axial force there? Well, of course, perhaps I haven't chosen an especially good example here, but if I go back to the full model, if I turn off the axial force, maybe go to the top view, and again, manipulating the model to make it easier to see and visualize. So that's essentially kind of what we have here. We've got the edge beam that you see there. So that axial force is caused by the component of the the horizontal component of the inclined column. So again, I hadn't chosen an especially good example there. But again, I won't kind of redo it. I won't come to the beam there and redo it. Again, it's something that you can test. Again, it's good to do these kind of small tests to experiment and get a better feel for the analysis as well as a given software package. So whether you're using GSA or ETABS or some other software package, again, doing these small experiments with your analysis can really help to aid understanding. So that's really all I wanted to say on rigid links. So now I'll move on. Sorry, that was all I wanted to say on offset beams. Now I'll move on to rigid links. So I'll start by getting rid of my analysis results. I'll go to model. I'll also get rid of the elements, so delete all of the elements I've got in the analysis layer and switch back to the design layer. Turn off the shading. So as you see, we've got our columns here. I'll turn back on the column shapes, so we've got a reference. So you remember from the lecture, I was questioning whether it's correct to connect a 1D element to a single node in a 2D element. And again, it's very much about the kind of stiffnesses of the two. And again, that's something that you can investigate. But how can we capture that in an analysis? And you can do what I'm about to show you in GSA, obviously, but also in ETABS, and I think in the bulk of modern software packages that are available to you. So to start maybe with the most kind of straightforward way, at least that's available in GSA. So again, we're in the design layer, and this only works in the design layer. And that's before you create any elements in the main model. So if I choose my selection tool, and let me just select the 4 2D members here, so you see them selected in purple. So I want to create rigid links. So if we come to the right-hand side, we've got both the tools here for offsetting, but also there's in the automatic offsets, which is maybe a strange place for it, actually, perhaps because I've selected the beams as well. Let me just refine my selection to the 2D members. Okay, so the reason the automatic offsets was available before was because I'd selected everything. But I've now selected the 2D members that you see there, and the only option that's left there is internal. So it's essentially looking at internal constraints. And in GSA terms, what that means is where you've got a beam, say, passing through or across the slab, it'll essentially mesh to that, and it'll account for the size of the element itself. So that's maybe a bit of a convoluted description, but if I click internal, you can maybe see what I mean. And this is why I put in the square column as well as leaving the arms the circular ones. So you see here, and remembering in the design layer, we're seeing the mesh shown in faint that will be created. So these blue lines show the rigid constraints. If you go to the display methods dialog, you can see rigid constraints is ticked. If I untick that, these should disappear. I'm not sure why they don't. Perhaps it's just because I'm in the design layer. Anyway, if for whatever reason it isn't showing, that's where you'd choose to tick to show your rigid constraints. Well, I wasn't expecting that. Anyway, what this is showing is that we've got the node that the stick is connected to. This is then the size of the column itself, so a circular column, as you see there, going through the slab, as you see. And what the software has done is essentially give you a set of rigid links or rigid constraints. And again, I discussed these in the lecture. I'll convert this into 2D elements in a bit, but you can hopefully see here that you get this very skewed arrangement of elements that, well, even if it does analyze, I'm really not convinced I would trust the actual results from something like this. And that's really just a function of the shape of the column. So, and also because it's on perhaps the edge of the slab. If I come to the square column in the center, and this is the reason I added it in, you can see you get a much, well, certainly an improved mesh around the square. But again, depending on the size of the column, again, you might want to check that you're happy with the size of the mesh and the way it's been refined. So just so maybe we can see that in a bit clearer, we go to Model Coordination Tools, Create Elements from Members, click All, click OK. And now it's put on the rigid links. So if I come to the analysis layer, you can now kind of see the actual elements that have been created. So really, I'm not especially a fan of this personally. I wouldn't sort of use this in terms of an analysis. I just wouldn't have confidence in the results that you would get out of these elements. It's a bit of an improvement here with, I'll switch on the nodes. So again, you see the rigid links come to each of the actual nodes on the 2D elements. If you wanted to see where all of this is actually defined in the software, if you come to the Explorer on the left-hand side, if you come down to the constraints option, if you choose rigid constraints, you can see these are all the constraints which have just been created by these software. But again, I'm not especially a fan. Well, certainly that's okay, but I'm not really a fan of what's been created there. And if I maybe go back to this, just to check if I was right. Yes, so in the analysis layer, once you've created the rigid links, that essentially turns on and off the lines. So it's really nice that the automatic tool is there, but it perhaps it has got a bit to go until it gets a better, well, at least a more refined algorithm to split up the elements around these columns, especially with kind of circular columns or columns, I imagine, with a odd shape. Now that's one way to create the rigid links. Essentially letting GSA do it all for you. But you can do it all by hand as well. So if we get rid of all of this, so going back to where we started with coordination tools, delete all my elements. So there isn't anything left on the analysis layer. Control Alt D takes me back to the design layer. I will select the 2D members I had before, and I will uncheck the internal constraints, and you see that is gone from the design layer. So what's the other way of applying them? So you can do that after you've created the mesh in the design layer. So the only perhaps issue there is once you've created the mesh and you've started to work on that mesh, it means you can't then delete the mesh and alter things in the design layer without essentially deleting all the work that you've done. So that's kind of the compromise. But I'll show you essentially the process anyway. So create elements from members, all, and so this is just taking what we have here. And if I switch to this design layer, you can see the actual elements. So again, there isn't anything especially special here. So again, that's our 2D element mesh. Maybe if I take a top view, and we're going to kind of stick with this column here. So just so it's easy for me to work with this zone, I'm going to take the volume tool and just look at a patch of elements there. So you can see that I've got my column, the elements. If I look down from above, you can see actually the elements themselves are quite a bit bigger than the size of the column. So how do we maybe, or what are the options that we have now? So I'll open the rigid constraints dialog box. So again, on the Explorer, go to rigid constraints, and we get the dialog coming up. If I hold down Control and press 2 on my number pad, that moves it to the bottom of my screen. If I hold down Control and press 8, that moves the kind of patch to the top. So again, I've got the bit I'm actually working with. So you could switch on the element numbers and type these in to the list there. Personally, I would be, well, typically I wouldn't go to that length. Let's turn those off. To be honest, I don't know what's going to happen if I press the wizard. So again, you could use this. You could type in the elements, the node numbers, because we're constraining the nodes. But again, I wouldn't do that. The way I would do this is, again, we're not looking at stage construction, so that's all. So we want to choose the nodes now which are constrained. So if I go to my node selection tool, turn that up. We go to my node selection tool here. So I want to select essentially the nodes. So if I hold down Shift, I can select, let's just select some nodes here. So I can select all of these. I can do Control C or use the copy tool at the top. I select nodes in the rigid constraints, and you can see that's pasted all of the nodes into this. Again, if you wanted to, you could have saved those nodes as a list of names, and the list could have been put in there, and I'll show you that perhaps with the next bit of the example. So that's all of the nodes which are going to be constrained. You then need to select what's called the master node. So I'll turn back on the node numbering. So depending on the type of rigid constraint that you apply, essentially the linked nodes behave as the master node does. So if you get a rotation in the master node, that will give you a rotation in the linked nodes. So again, I'd recommend you look at the GSA help, and it explains it all in detail. It also explains what all of the options are. So you can see there's a whole range of types of linkage. So maybe you've got the option to only have a rigid link in the plane, so the XY plane. So typically that might be used if you were modeling a diaphragm of the floor. So again, this is what I talked about in my lecture as well, where you in plane it's very stiff, so you've got that rigid plane. Out of plane it isn't. But here we're modeling the kind of column to slab connection. It's rigid. I'm essentially saying in all directions. It's a monolithic connection, so I should somewhere here see all. So that's the first one. So that's all, meaning it's constrained both translationally and rotationally. All pin means I believe, I need to check the help, but translational restraint, but there's no connectivity or link rotationally. But again, if you look at the help, it describes all of these. And it's as simple as that. If I then just click out of that, I didn't type in the master node, so I'm going to choose the node that the column connects to. So if I type in 128, if I click OK, I should now, because I didn't put all there, I should now see it appearing there. So again, you've got the name of the rigid link. So rigid 1 is record 1, and it's telling you it's all. So that's a completely encastrate or completely monolithic a rigid node, and it's kind of clearly showing us kind of where it's connected to. If I turned off the rigid constraints, incidentally, you would still see blue dots for nodes which are constrained. Again, just as a reminder of what's being constrained. It's showing you that because I've got my I've got a tick in here, and also if I come out of this, I'll just turn back on my rigid constraints, apply. I believe also in tools, in preferences, and again, it's been some time before I've had since I've had to look for this. In one of the settings, and I don't think I'll find it now. In one of the settings, in one of the preferences, it allows you to switch on and off the coloring of those nodes. If I find it, again, I'll post it in the description. So let's just put on a rigid link onto this column. If I go above, if I turn off the numbers, we can see it there. But of course, the problem is that actually I've said that the column is almost as big, well, it is as big essentially as a size of these two elements, giving us a big rigid zone. In reality, that isn't the case. So how do we address that? So just coming back to the starting view, I will select the rigid link. I will delete it. So what we want to do is manipulate the elements. Now we could go back into the design layer. We could create a region around the column and change the mesh size. But again, if we're happy we've got the model working and running, if we know we're not going to go back and delete all of our elements, we can actually operate on the elements in the analysis layer. So maybe it's easier to do this from a view looking down on top. So we can see the actual 2D elements there, and the stick element is there, but you can see the size of the column. So we're going to use the sculpt tools to alter the elements. So we could use the sculpt option there, 2D elements, and if I can find it, it's the refine quad elements tool or option. But the other place that you can find that is the dialog up here at the top. Again, the kind of shortcut to the sculpt options. I'm going to turn on also the element edges. So you remember before, you can also turn it on in the display methods that you see there. But as I described, an element is defined in terms of its edges, in terms of some of the inputs and manipulations that you can do. So in terms of the element that you see there, this element, that's edge 1, this element, that's edge 1. So again, we could accept that. Again, there isn't an issue with that. But actually, just for the sake of convenience, I'd like to actually spin this around so edge 1 is maybe along the bottom of the screen. So before I refine the elements, I'll come here, and there's an option, if I can find it, to spin 2D elements. So if you watch the arrow, and if I click OK, you see it's spinning it around. So that's then becomes edge 1. If I go to the element beside it, that then is also edge 1. You can do this with multiple selections. So I've selected the two elements side by side, and you can see now I'm just rotating both. So it just gives me, again, it's personally a way that I like to work, but again, it doesn't actually affect the analysis at all. So what we want to do is refine these elements. So I'm saying that this element it doesn't really, it's too big in terms of capturing the rigid region. So I want essentially to refine it. Now I could start manipulating the elements by hand, but a quick way to do this is again to choose the element I want to refine. I choose the refine quad elements, which is what we've got there. And if I click OK, so the dialog box here essentially tells us what we're actually going to do in terms of the refinement. So when it says refine corner, so corner 1 is here. Because remember, we go from 1 to 2, 2 to 3, 3 to 4, and then 4 back to 1. So corner 1 is there. So if I choose preview, you see it's refined the 2D element, but starting with corner 1, which obviously isn't what we really want. What we want, and again, you could just do this by trial and error, but what we want is to start with refinement at point 2. So if I click preview, that's kind of what I want. And if I click OK. But obviously there's an issue here. There's no connectivity between the 8-noded element that you see there, and obviously this is an 8-noded element as well. If I go to graphics actually, and graphic settings, and I choose the highlight edges option, which actually I perhaps should have done at the start, and I'll click OK. So you see that between these elements, for example, there's nothing highlighted between here and here, which shows there's where you've got compatibility essentially between the elements. There's no nodes that are unconnected. But you see along the edge there, it's showing you the darker line there, there, and there. So it's a graphical way of showing you that, well, there's actually a discontinuity in the mesh, there's no connection, and that's something that you need to resolve. So I now want to come to the element here. Again, I do exactly the same thing I want to do refinement. So again, we've got the arrows. This is edge 1 going from 1 to 2. So we know this time we want to start at corner 1. If I go preview just to check before I do this, you can see it's giving me what I want. You can see now we do have a connectivity between the elements. So the edge, the kind of dark line is gone. There's a dark line here just because that's the edge of the slab. And if I click OK, so though it isn't perfect, you can see if I take off the shrink tool, you can see that's a much better representation of the size of this column. In reality, you might do it again, because really this should be perhaps inside the column itself. But again, the question is, does that actually matter? So you could actually test that out. Again, it depends very much on the size of the slab and the column itself. But I'm going to accept this for the purposes of the example that we have here. So just turning the view so it's easier to see. So remembering, turning back the view, that really these then are the elements we want to constrain, the two adjacent to the column point. So I will turn that a bit. So it's exactly the same process as before. I'm going to choose my node selection tool. I'm going to just drag this time around it. So I've captured all the nodes I want to. I press Control C. I come back to the rigid constraints. It's again, stages all because we're not doing staged construction. I press Control V to paste the list of nodes in. Excuse me. I've got my node here that's been connected, so I will type in 128. Let's have the linkages all as before, and there you go. So you can see that's now my rigid constraint being applied locally around the actual column itself. If I go above, again, just by way of example, take off shrink. So again, you can see again these blue dots indicating the nodes which are rigidly connected. Again, perhaps you might want to refine this one more time so you get the inner square kind of in here. But again, does it really matter? If you were really concerned, I suppose perhaps you might not link the node there on the corner and these node there. Again, it might not be ideal in terms of the of the connectivity of the rigid links, not connecting these corner nodes. But again, does it really matter? You could test that out quite easily. So that is basically how to apply rigid links. And you could obviously go through the entire structure and do this by hand. But as you can see, it's quite a time-consuming thing to do. So although ideally you would do it in the design layer, as we saw, that might not be ideal. You could test out you could actually test out a model where you compare the results that you get with this arrangement that you've done by hand to the very kind of skewed mesh that GSA created itself, and see actually does it make an enormous difference. The one thing I did say I would do is look at how to do this by making a list of the actual of the nodes. So if I reselect the nodes, so again I've selected some of the nodes, I've missed a few, so if I do control, so if I do shift, I can add to the selection. I will right click, I will save selection by list, so you can really do that with anything you've selected. So that's just giving it a name. So now if I come to the nodes, you see the actual name I've typed in has appeared there. So it's again, you can give lists of nodes sort of meaningful names. So if you knew this was the column on grid line B2, you could type B2, or you could define the nodes as B2, and then it makes it and then you actually can keep track of which rigid link relates to a particular column. Again, it really depends how much effort you want to go to in defining the rigid links themselves. So I'll save it again. So if I go back to the entire model itself, I will close the rigid link dialog. Again, just as a reminder, in the Explorer, in constraints and rigid constraints, that's what we've just specified. I will turn off the nodes just to make things clearer. I'll turn off shrink as well, although really we're not going to use this much. So the final thing I'll touch on is how to actually alter the element properties. So for example, maybe you want to capture cracking, maybe you want to define a virtual element. So perhaps you only want to define the beam along the edge as a way of applying load to the beam, rather than trying to apply it to the 2D elements. So the beam is really only there as a virtual element to actually connect loads to the slab. So you might want to take out the stiffness of the beam, so it's not actually acting as part of the structural system. Again, it's very much up to you to decide how you want to apply loads, how you want to modify the actual properties themselves. So let's start with the most kind of straightforward way of altering the properties, or the most straightforward elements to alter, and that is these stick elements. So if we go to properties, to the sectional library where the sticks are defined, so that's essentially the sectional library itself. These are the columns that we defined before. That should really say concrete, as should that. I'm not sure why that wasn't there from before, but we'll come back to this in a second. But we've got the properties there, but you can see at the bottom there's also a tab for section modifiers. So what this will allow you to do is for each of the properties that you defined, you can apply a modifier to a given property. So whether it's the area, whether it's the stiffness in Y and Z, the J value, these shear area factors, again, it's all here. You could type this in by hand, or again, if you go and if you select one of the properties, if you then select the wizard, you can type it all in here. So again, just as an example, if I said that was sort of 50%, and you can choose to set it to an explicit value or by a percentage. If I click OK, you should see the area there go from 100% to 50%. If I click OK, that's telling you that that's now gone to 50%. So in the analysis, it's going to modify the actual properties of that section based on the modifier that we've applied there. And obviously you could imagine that if you've got your beam split into a whole series of sections, you can give each section its own property and modify the actual stiffness, again, perhaps to reflect cracking. Going back to the section library, you can see in the column here, it's picked up as a reminder to us that we've modified the actual column itself. If I come out of that for a second and go back to the analysis, if I choose my selection tool, that was the columns we'd modified. So if I select the column that you see there, if I look in the list here, I'm expecting, so I've selected the column. You can see the property name there. It's telling me it's property 1, the 300 diameter column, and it's indicating to me or reminding me that I've modified those particular properties. So it's perhaps very easy to modify stick elements just because, well, it's a fairly kind of simple thing to do. So we haven't altered the actual material property, we've altered the actual element property itself. And I'll come to that in a bit when I look at the distinction between the two. So if we close this and now look maybe at 2D element properties. So there's no second tab, but what you have here, if we scroll along, is you can alter the actual properties either of the in-plane stiffness, the bending stiffness, or the shear stiffness, amongst others. Again, you can type them in directly, or you can go to the actual wizard, and if we click next, again, it's the same dialog as well. So you can alter the bending stiffness, of course, it's the bending stiffness in all directions. Because again, they're ice, or at least here, it's a isotropic, excuse me, it's an isotropic modifier, so it's altering it in all directions. But that's one way to alter the properties of the 2D elements. And again, you can define your slab maybe in areas of hogging and sagging, give them different properties, and then give each of those its own stiffness. So that's one way of maybe looking at the effect of cracking and looking at a more rigorous approach to looking at the deflection of slabs. Unfortunately, there's no automatic way at present in GSA to actually alter, for the software to alter the section stiffness based on the bending moment. It's still very much a manual process, unfortunately. So those are the two ways that we can alter the properties of the elements. But of course, the other way we can modify them is the actual material definition itself. And that's what I'll end on just now. So if we look at the materials dialog, I'll just close this. And again, I'll be looking at concrete. So this is the actual kind of inbuilt material property. So that's what we chose to define our elements as. If we click the wizard, again, we can see the actual properties here. So if we wanted to, we could actually alter the property of the material. So for example, we've got the strength there, we've got the elastic modulus that you see there, which is grayed out. But again, we've got the chance to alter these particular properties. So the reason the E-value here is grayed out is it's part of the default properties of the material. But what we can do if we come along the options, again, some of these are for section design, so again, you can look at that in the help menu. But if you come to the analysis tab, here you can alter the actual properties. So maybe 1,000, I don't know. And I was actually expecting that to change there. I click OK. I'm not sure I didn't do that the first time, but you see, and we've got the elastic modulus as a design property and the analysis property that we just set. So now if we come back to the element properties and go back to 2D properties here, and I'll, for the sake of convenience, put one above the other just so we can see what we're doing. So at the bottom we've got the 2D properties, so that's the properties that we've used to define the actual elements in the analysis. And we've got the dialog here for the actual material itself. So we've got the column here that says analysis. So if you leave that as based on these grade, it'll simply take it from here, and then it'll choose the actual the analysis property that we've defined. There are other options. I'll come to these in a second. So that's one way of altering the E value. So we can alter it here, and that's then what's going to be used in the actual analysis versus the actual design parts of GSA. But then if we come back to the left-hand side, we've got materials, but now we've got advanced. If we come to material properties, and the screen's now getting a bit full, but if I maybe just put this on top. So you remember here where it's got material analysis, when it says from grade, is simply taking it from the material grades dialog that we see here, which is the basic one we've got in materials concrete. But you can also choose from the advanced material properties. So these are ones that you've maybe defined yourself. So if I come here, you see it's given me options for 1 steel, 2 concrete. So 1, material 1, steel, material 2, concrete. So why might you want to do that? So I'll just put that on top. So let's define a new property. I'll just use these wizard for this. So we're going to look at orthotropic concrete. So if I go to the options here, I want elastic orthotropic, and I want to base it on a concrete. So just to remind me what it is, I'm going to call it, so it's going to be based on concrete. I should have done that first. Excuse me. So it's orthotropic concrete. By pressing that button, essentially, it's put in the default concrete properties in the dialogues, which follows. So it's not a bit, well, so it's a bit convoluted. But if you press that, essentially puts in the default properties, so it's easier to alter them. So then just putting in the name, changing that back to elastic orthotropic. If I then go next, so what you see here is perhaps the most, well, as the name suggests, the kind of advanced options for entering the properties of the actual materials. So if we're applying these to 2D elements, and GSA has 1D, 2D, and 3D elements, if you're applying it to 2D elements, you can actually then define the elastic modulus in the X and Y directions, essentially allowing you to change the stiffness in each of those directions. So again, you can work out what these properties would be if you maybe want to do a more rigorous type of check, or perhaps you're looking at perhaps rib slabs, hollow core slabs. Maybe again you're looking at a cracking of the sections. Again, it's something that you can account for here. If I then press finish, that's it, and you can see it's now added my orthotropic concrete to the materials properties options. Unfortunately, it doesn't really show the actual values there. You need to go to more and then come back into the actual dialogues. If I just come back and go through the same process again, if I initialize to concrete, if I just stick with the isotropic option, if I click next, you see it's a much more basic dialog again, it's isotropic properties. So again, there really is there's much fewer bits of information that's required. But now we've defined these in our material properties, how do we then apply them to the actual elements themselves? So again, it's simply coming back to the analysis option that you see there. If I go to my drop down, I can see I've got my orthotropic concrete and isotropic concrete. If I choose orthotropic concrete, that's basically now set that material properties to the 2.7 thick slab. So that's then basically defined how that slab's going to behave in terms of the material properties. So whether or not I alter the bending stiffness, say here, we're going to get an orthotropic type response based on how we've defined the actual material itself. So really the best way to look at all of this is really, I think, to create models of your own, to apply simple load cases, to test these elements. I'm sorry, to test the actual models, maybe run it just under a simple self-weight case to see what happens. Maybe test the orthotropic properties by maybe kind of changing from maybe perhaps the same E value in each direction and then slowly reducing the E value in one direction. And you should see the results starting to change, going from a multi-way spanning slab, say, to one that's only spanning in the stiff direction. That would be a way of checking that it's behaving as you expect. And that's really all I was going to cover in this tutorial. So hopefully that's going to help in the more research and investigative part of the project work if you choose to use GSA. Again, there's no real shortcut to understanding, but certainly I do think GSA is very good. It's very easy, I think, to learn. It's fantastic in terms of the output, the clarity of the output, and I really would recommend it if you don't have another piece of software that you have a particular affinity for. So I hope that's been useful. Again, as I said, I'll give these models to Dr. Vollum, and if there's any questions, please don't hesitate to get in touch with me. Thank you.